Hello, PreCalc. It is Thursday, and we are looking at this on 1/7/16, and I'm going to jot down the time. So it's 11:32 here. I'm making this while students are at lunch, so I'll get it up when I get home. All right. What I wanted to teach you today, reteach you, you've seen all this, is determinants. Probably not all of what I've taught you, will teach you today, has stuck from the past, but probably some of it has. So let's all get on the same level ground, and I'm going to give you a matrix, and that matrix is a 2 by 2, 1, 2, 3, 4. And there's a symbol for the determinant. A determinant is a number that is assigned to this matrix. And a matrix has to be square to have a determinant, and they often are, so comes in handy. And when I'm talking about not the matrix itself, but its determinant, I use these vertical lines. Instead of the bracket box that's formed, I now have these lines. And everyone knows that I'm talking about the determinant of that matrix. Well, you'll see why we need to do determinants. They're going to be useful to us, but for this lesson, we're just going to find them. In order to find the determinant of a 2 by 2, you multiply along this arrow and you subtract along this arrow. So 1 times 4 is 1, 3 times 2 is 6, but we're going to subtract that number, which gets a little tricky when this arrow provides a negative number, then it becomes a double negative or a positive. So whatever's along this diagonal, we're going to use the sign unaltered, and when we are multiplying along this diagonal, whatever sign we get, we're going to use the opposite. So I state that by saying we're going to use the positive product along here and the negative product along here. And some people remember that this direction is positive by thinking of the United States. There's Maine, Florida, Texas. All right. And so when we have the United States, a lot of people feel that moving from the south to the north is a negative experience, and moving from the north to the south is a positive experience. Now, I happen to love the north, so not a very good memory aid for me. So, but whatever helps you. This is the positive. We keep the sign the same. This is the negative. We will alter the signs. All right, I want to see these notes tomorrow if I remember. I keep trying to remember, so please take good ones. All right, then with this number and this number, you actually add them, and a -6 and a +4 gives you a -2. The determinant for that original matrix is -2. All right, let's see, you do one. All right, I want the determinant of -1, 1, -2, 2. Go ahead and do that. I added some negative signs to make sure you understand what I mean. And here's what I mean. So I'm going to multiply along this, and I'll call that the positive diagonal. In other words, I'm not going to mess with the signs. They are what they are. So -1 times 2 is a -2. Along this diagonal, I'm going to change the signs, so it's like the negative of whatever is on this diagonal. So -2 times 1 is -2, but I'm going to think of that as a -2 or a +2. When I add these two, I get a determinant of 0. Hopefully you did as well. And try one more. Find the determinant of 2 minus 3, 1, 2. Find that determinant. Are you getting a 4 and a -3, which is a +3? And when you add those two, are you getting a 7? Hopefully. They can be fractional, so I guess I will give you another one. 0, 3/2, 2 and 4. You can pause to try that one. And the answer is positive diagonal, 0 times 4 is 0. Negative diagonal, 2 times 3/2 is a positive 3. But I'm going, because it's on the negative diagonal, I'm going to use the opposite sign. Negative 3. Add those two. I get a -3. Alright, so 2 by 2's. There can be a formula observed from that, but I think it's better to just remember the principles of it. Alright, going to a 3 by 3. Let's look at 0, 3, 4, 2, -1, 0, and 1 to 1. Check the time. 11:32 I started, and it's been about 10 minutes. So I will do this one. In order to do the determinant, you're going to repeat the first two columns. And notice I just rewrote that one, and then I rewrote that one. That creates 3 diagonals this way with 3 elements in each. So if I tried to make a diagonal here, it would only have 2 and 1. So I'm looking for the diagonals that have 3 numbers. So this is moving south, so we're going to not alter the signs. So we have 0 times -1 times 1, it's a 0. We have 2 times 2 times 4, which is going to give us 16. And notice I'm going to add that to the diagonal previous. And then 1 times, mine are all askew, 1 times 3 times 0. If I line them up better than I did. So you add all 3 diagonals and get 16. And now we're going to go the other way, remembering that's the negative direction. So 4 times -1 is -4. Minus a -4 is a +4. 0, it's just 0. Doesn't matter, plus or minus. 3 times 1 times 2 is 6, so I'm going to use -6. So the diagonals going in this direction add up to -2. And when I add those two numbers, I get a 14. That's the diagonal for that determinant. I mean, that's the determinant for that matrix. Alright, there's another way to do that, and you'll say, well, this way's fine, let's stick with it. The other way actually comes in more helpful when you have to do 4 by 4s and 5 by 5s. So I will teach you the other way, and hopefully I come up with the 14 as well. To do that, I'm going to shut down this part and be right back. I'm going to recopy this same problem, and I'll be back with you in a second.